In this video, we solve several limit problems using the epsilon-delta definition. You may watch this video after watching the OGE video that discuss one problem and also the theory video that explain the theory behind the epsilon-delta definition. You can find the link in the description. So in this video, we're gonna solve several problems in different ranges. For example, we have linear problems and quadratic with 2 and 3 terms, and cubic and square root functions, rational functions, and then also square root in rational form. So these are all type of problems. We have 9 problems here. So let's see how we solve each one. So I'm going to use different logical arguments, like sometimes double implications and sometimes single implications, and also sometimes like a simple calculations. So let's see how we can solve each one. So let's start with the first. Let's start with the definition. So the precise definition. So what's a precise definition? So we say that the limit when x goes to a, fx equal L, if and only if, what we call the double implication, if and only if for all epsilon, that means for any given epsilon, there is a delta which is a function of epsilon, such that for all x in the domain of the function, because this is very important, especially when there is a discontinuity. So for square root functions or rational functions, you have to be very careful with this one. Then the 0 less than x minus a less than delta implies the fx, the difference between the function and the limit is less than epsilon. So if you can prove that for all epsilon there's a delta, and for all x in the domain, the first one implies the second one. That means if x is within delta this distance, then you want to make sure that the function is within the L. The function is within the epsilon distance to the L. So that's the what we call the precise definition or the limit definition. Good. So let's look at this problem. So we're gonna go to the first problem. So what it says that, so we have so prove that the limit when x goes to let's say 8, just pick a number, 1/2 x minus 3, since you have more terms you have to put a parenthesis around, equal 1. So that's what we're trying to do. Where is 1 coming from? And you can see that 1/2 x minus 3 is a linear function, is a polynomial. So that means you can just plug in the value to find, because these are like continuous functions. So you can plug in the value, you plug in 8, and you can see that you get 1. So that's where the 1 coming from. But so what we're trying to do right now is we're going to prove that that's exactly the result. So to prove a problem like this, what we're going to do, so we can use the epsilon definition. So we pick a general epsilon, so any epsilon, and then we try to find a delta that implies this condition. So let's see how the argument gonna work. So the proof. So what we can do, we're gonna pick a epsilon. So let's say let epsilon positive. So you pick a positive epsilon, and then what we need to do, so need to show that. So let's see how to write a complete logical proof. Okay, so need to show that there is a delta. There is a delta which is a function of epsilon, that means depend on epsilon, such that 0 x minus 8 less than delta implies the function is 1/2 x minus 3 minus the limit. In this case, it is 1 actually. Minus 1, that's the limit we are talking about. 1 is less than epsilon. So the goal is to find this delta. So, and then you can see that this is the function. This is the function, and that is L. So this is L. So what we normally do is, because we don't know what that delta is, so we start with what we need to prove and then think about the condition and go forward. So what we do, so we can say now we're gonna pick what we want to prove. So what we want to prove is 1/2 x minus 3 minus 1 less than epsilon. That's what we want to prove. So, and then we know that this if and only if, that means double implication, we're going to simplify inside. So if you simplify inside, what do you get? 1/2 x minus 4, which is less than epsilon. So they're equivalent. Now what we're going to do, we're going to multiply both sides by 1/2. So that means this is if and only if we multiply inside, like both sides, you can just bring inside by 2. Why we do that? Because your goal is to create the x minus 8 term. Now when you multiply, you can see this is again if and only if x minus, so you're going to get x minus 8 less than 2 epsilon. So you can see that this is exactly what we want to prove. So what we're going to do, so this can give an option. So you can see that if you pick this part as delta, then this implies that the condition. So that means this simply going to give you the delta. So one good example option would be delta equal 2 epsilon. You really don't want to do that because you can pick any delta which is smaller than this. So one, what do you say, optimal option would be here. It's not the optimal option. So would be here 2 epsilon. But you can pick any delta which is smaller than 2 epsilon. For example, you can pick delta equal epsilon. That still works because delta is the gap or the radius from 8. So that means even if you pick a smaller one, that still works because that's still within that. So that means you can pick any smaller delta for this one. But we're gonna go with this one because that's what we directly get from this one. But again, you can pick anything. So now we can say, so thus, so it's very simple now argument. Thus, because it's all if and only if. That means if you start with one, you get the other one. So thus, choosing delta equal to epsilon, or you can pick any, like for example, you can pick delta equal epsilon. That we can do later in another example. So we have because of this all double implications, you can say 0 less than x minus 8 less than delta implies. Now we can write just all like one direction. For example, you can write this one go this way, and then this one go that way, and all go like a backward. Only like a left. So then you get the answer. So this implies that the first one. So you can say 1/2 x minus 3 minus L in this case 1 less than epsilon. That's exactly what we want to prove. So that's the function, and this is the limit. So this completes the proof. This is the epsilon delta argument. So this complete, because if you pick any epsilon and you prove that there is a delta, that works. Okay, so this completes the proof. This completes the proof. Good. So you can see that's very simple. It's not that difficult, but there are some logical arguments that you want to make. So let's look at the next problem. So as the next one, we have proved that limit x goes to 2 x cube equal 8. Again, x cube is a polynomial, so you can plug in the value and get the limit, so which is 8. But let's see how we can prove this. So in this time, I'm going to use a slightly different argument. and let's see how it works. So the proof, let's say let epsilon be positive. So you pick any positive epsilon. Then note that so we're going to start what we want to prove. We're going to start with x3 minus 8 equal, and we know that we can factor this. How to factor this? So you can see that 8 means 2 to the 3. So we can use the difference of cube formula. We know that a3 minus b3 equal a minus b. That's the first factor. The second factor is a squared plus ab plus b squared. So that is how you're going to factor cubes. Since 8 is 2 cube, we can use that. So because of that, if you look at those two factors, we can write this like this: the absolute value, the first factor, minus times the second factor. You can write it like that because it's a product, plus 2x plus 4. So this is true, they are equal. Now what we're going to do, so the goal is to find the because x minus 2, that so we need x minus 2, that's we already have. So the goal is to find the largest value of this factor. So find the largest value of the rest of the function. Find rest of the expression. Find the largest value. That's what we need. Largest value. Find the largest value. But the problem is we don't know what's the largest value, because this is just a polynomial. It can have any value because this goes to infinity. So there's no largest value here. So that means we need to restrict the domain. So what we're going to do, we're going to restrict x minus 2. So we're going to say, so we're going to start with like a, so let x minus 2 is within 1. So we're going to pick values within. You can pick any value you like here. So let's say 1. So that means what? That means if you look at this interval, what this means, it means that all the values which are 1 unit away from 2. So that means you add 1, so you get 3, and you subtract, you get 1. So those are all the values that you're going to get. Since we are looking for the largest value, I'm going to pick the largest value here. So pick the largest value. So the largest value in this case 3 is not in there, but we are looking for a bound. So that means you can say 3 here. What we can do, we're going to see what will happen to this factor. So if you put x equal 3, x squared means 9 plus 2 times 3 means 6 plus 4. That means this simplifies to 19. So this, you can see that the largest possible value under this condition that you can get is 19. So that means but if you restrict this one to delta, so if you restrict this one to delta, let's say this is smaller than delta, that means the largest you can get here is 19 delta, because the other one gives a 90. So what your goal is to find the largest value of the other factor. So the condition is you want to make sure that this is smaller than epsilon. So what we're going to do, we're going to pick a really smaller delta such that 19 times delta, you don't need 90, you can say 20 here for the safe side, but 19 is the largest possible value you can get. So what we're going to do, you're going to pick a really small delta so that the 19 delta is smaller than epsilon. So you can always do that, because you can pick a really small delta. That means you can make sure that 19 delta is smaller than epsilon. Actually, you can even have equal sign. So because we already have a strict inequality. So that's exactly how you're going to find delta. So after you get that, you want to make sure that you're going to pick a really smaller delta such that 19 delta is smaller than or equal to epsilon. So that means now we're going to solve this. So if you solve this, you can see this is 19 delta smaller than epsilon. This is the delta is than equal to is epsilon over 19. You can pick anything, like for example you can pick epsilon over 20. So anything works. So it's 19 or more. Now we have all the conditions we need. So that means now what happened, so we have now and, so the condition is and, so this says that x minus 2 less than epsilon over 19. Now what we're going to do, you want to make sure that both conditions are satisfied. So we're going to pick a delta which is the smallest of the two. That's what we're going to do. So what we're going to now choose. So that's the interesting part. Now choose delta which is the minimum of those two, minimum of 1 or and epsilon 19, because if you pick the minimum then it's guaranteed that it satisfies both of them. So now let's see how the rest of the argument works. So then so you can write this now. Then you can say if epsilon 0 less than x minus in this case 8, actually it is 2, so 2 less than delta, this implies that, because since delta is the minimum, this implies that x minus 2 less than any of them. So that means, for example, epsilon 19, we pick the minimum. Since we pick the minimum, it is smaller than any of them. Now what we're going to multiply by 19 both sides, so it's x minus 2 times 19 less than epsilon. But we know that since 19 is the largest value, we can bring that back factor back here. So we can bring the other factor here. So it is x squared plus 2x plus 4. That's the other factor, which is less than epsilon. But now we're going to combine them, and we know that this side is smaller than 19, so this implication works. So this implication is true because 90 is the largest value. So if you replace something by something smaller, then still it should valid. Now we're going to combine them. You're going to multiply through. Once you multiply through, so you can write this one. I will write the extra step here. You really don't need that, and you're going to bring into one product like that. Now you can see that because of the difference of cubes argument, this simply equals to x3 minus 8 less than epsilon, and that's exactly what we have to prove. That's exactly how the argument works. So it directly implies that way. So that means, so thus what we prove. So we prove that for all epsilon, there is a delta which is depend on epsilon, such that 0 x minus 2 less than delta implies x3 minus 8 less than epsilon. That's exactly the definition. So therefore, by the definition, that's how we write the argument. Therefore, by the definition, the limit x goes to 2, x cube equal 8. So that completes the proof. So you can see that it's a really nice, neat argument. So let's look at the next example. So as the next example, we have proved that the limit when t goes to 3, t plus 1 square root equal 2. So we prove, and we notice something here. We see that since this square root function, we want to make sure this part is greater than or equal 0. So this implies t greater than or equal negative 1. So that means you want to make sure that you are not going to plug in anything which is smaller than negative 1. Let's see how we can take care of that later. So again, so we're going to use a similar argument. So we're going to say let epsilon greater than 0. Then note that, so what we're going to do, we're going to start with what we need to prove. Note that t plus 1 square root minus 2, that's the one we're going to consider. Subtract the limit from the function. So what we're going to simplify this one. We are not going to write anything with epsilon here. We just simplify this expression. So this is equals, what we're going to do, when you get square root, what we normally do is we're going to multiply by a special one, or the special one is the conjugate, top and bottom, the numerator and the denominator. So that's the argument we're going to use here. So that means we have t plus 1 square root minus 2 times, you're going to multiply the top and bottom by the conjugate. Conjugate means you change the sign here in between, not inside. Change the sign uh, for the subtraction. So go with plus sign, and then also we do that with the minus sign. So this is simply 1. So you can always multiply by 1. So we do that, and it's under uh, absolute sign. Now you can see that when you multiply the top, we can use this result. We know that if you have a minus b with a plus b, you're gonna get a squared minus b squared. That's exactly the reason why we multiply by the conjugate. So one is the conjugate of the other. So, and because of that, you're going to square the first one. So when you square the first one, you can get t plus 1. Minus, when you square the second one, you're going to get 4. So that's what you get for the top. For the bottom, and you can see that this is always greater than or equal 0. Actually, it's greater than or equal 1. This is square root. So it's always, we assume that's greater than or equal 0. So because of that, this whole expression is positive. So that means you can, so we still have the absolute value for the top, but for the bottom, you can take it out because that's a positive term. So plus 2, and then, so that's what you get. Now, you can see this again simplifies to the top, simplifies to t minus 3. So that's exactly the term that we want to bound. And the other thing I'm going to write as a separate term because then the argument would be much easier. So we have this. So now what we want to do is you want to find the largest value of this expression. You want to find the largest value of this expression. But this one is very clear because we know that the t plus 1 square root is greater than or equal 0. So that means the largest value you get when this is 0. So that's when you get the largest value. So that means you can see that this whole expression is less than or equal to 1/2. So you can write it like that. So that means you can write this one as so this is less than or equal to you can see this is less than or equal to but if you bound this one by delta, because this is smaller, you can see that this is smaller than 1/2 delta. 1/2 coming from the expression. We know that this expression, the whole expression, is less than or equal 1/2. 1/2 you get when t equal -1. That's when you get 1/2. Otherwise, this is smaller because you are dividing the numerator by something. So that means this is smaller. So always positive that. So we add a positive term to the new denominator. That means the fraction gets smaller. So and then so what we can do that we're gonna pick a small delta so that this 1/2 delta is smaller than epsilon. That's how we're trying to do, or equal. So we're going to pick a delta, smaller delta, which is so that 1/2 delta is smaller than epsilon. So that means if you solve for delta, you can see that delta is smaller. So what do you get from here? You see that delta is smaller than, less than or equal to 2 epsilon. So that means you can pick either 2 epsilon or any other epsilon, any other function of delta which is smaller than 2 epsilon. For example, delta equal epsilon. But there's something you have to be careful, because you know that you want to make sure that you do not pick any values of t which are less than -1. To guarantee that, what we're gonna do, we're gonna put extra condition on delta. So you say that. So now what we can do, now choose, this is interesting part, now choose delta equal the minimum of, just put a number here like 1 or 1/2, something like that, so that it doesn't go until -1. So you can see that if you put a delta like that, so you can see what we're trying to do is we try to go, this is 3, so you try to stay around this interval 4 and 2. You can see that the -1 is far away. So that means it's never reached -1. That means there is no any discontinuity here. Like there are no any undefined point. That's exactly how to do that. We just put a some number so that it doesn't go that far. That's why I put 1 here. Because if you don't put that there, the argument is wrong. and then we have and then we get the minimum of 1 and 2 epsilon. So once you do that, then you can write 0 less than t minus 3 less than delta implies that um, t minus 3 less than any of them. So for example 2 epsilon, because it's the minimum. We pick the delta as the minimum. Since the minimum, it is smaller than any of them. It's smaller than 1, it also is smaller than the other one, 2 epsilon. Now what we can do, we're gonna divide both sides by 2, so we can write this one as t minus 3 times 1/2 dividing both sides by 2. Now what we can do, we know that 1/2 is the largest value of the expression, so that means we can put that back in. So we're gonna put that back in, so we say t minus 3 times, we're gonna put the expression here. So what is the expression? It is t plus 1 square root plus 2 less than epsilon. Why? Because we know that that expression is bigger than 1/2. 1/2 is the largest value. So if you put something smaller, it is small. Now what we can do, we can write backward, and we know that this is if and only if you put the multiply by the conjugate. So this is if and only if, so they are equal. So what we can do, t minus 3, we can write, we can break it into t plus 1 square root minus 2 times t plus 1 square root plus 2. So the benefit is, because we know that this is exactly steps that is, that's why we can write this, like otherwise it's going to be like very surprising where this is coming from, but we know that this is exactly how we simplify this. So now what we can do, we're going to combine, you can see you can cancel this with that. So once you cancel that, so this is again if and only, because they are all equal. So if and only if, you can write this one as t plus 1 square root minus 2 less than epsilon. So now we have the proof. So that's exactly what we want to prove. So therefore, you can say therefore, by the definition, epsilon-delta, by the definition, you prove that the limit t goes to 3 t plus 1 square root equal 2. So that completes the proof. So let's look at the next problem. So we have proved that limit x goes to 2, 3x squared plus 4 equals 16. So we're going to use a similar argument. So the proof, so let epsilon be positive, and then say consider. So we're going to consider what we need to prove. So the 3x squared plus 4 minus 16. But we know that this is equals to, if you simplify, you can see that you're going to get 3x squared minus 12. That's what you get. And then what we can do is, we can factor, we can pull 3 out. So if you pull 3 out as a factor, you're going to get x squared minus 4. Now we can factor x squared minus 4 using the different squares. So that means what we can do is, we can write the x minus 2 here, and we separate the rest of the rest from this one. So we put the multiplication 3 times x plus 2. And then you can also combine, and you can write it like this. So we're going to say x minus 2, you're going to combine it, and we're going to put 3x plus 6. We're going to combine like that. And now the goal is to bound the second term. So to do that, we do as we did, because we know that there's no otherwise there's no largest value of that expression. So we need to find the largest value of this expression, but there's no largest value, it goes to infinity. So what we're going to do, we're going to bound the delta. So what we do as before, we're going to say we're going to pick a value x minus 2 less than 1, because that's going to restrict the x value. So this says that x is within 1, that means largest value is 3 and the smallest value is 1. Since we are looking for the largest value, we're going to pick, so that's the largest value 3. so we're going to use that value. So that means if you use 3, and you can see that it's a 3 times x, so it's 3 times 3 plus 9. That means this is less than 19, because this is an open interval. So that means what we want to make sure that is, so we want to make sure that this is less than epsilon. So what we're going to do, we're going to find a delta. We're going to find a delta which is smaller than in this case actually you get 15, so it's not 90, 15. So so we're gonna find a delta, so that the 15 times delta is smaller than epsilon, because we make sure that this is less than delta. So that's where the 15 coming from. So 15 times delta, we make sure that we find a smaller delta, so that 15 delta is smaller than epsilon. That you can always do. So pick a delta like that. So now we can write the rest of the argument. So now we can say now choose. So now I choose a delta which is the minimum of 1, and so you can see when you simplify for delta, you're gonna get delta is less than epsilon over 15. So you can pick this or any smaller values. So so we got epsilon of 50. So you can say epsilon 20. That works. So then what happened? Then because of this equality, and you can see that then 0 less than x minus, in this case 2 less than delta, implies that x minus 2 times x minus 2 epsilon x minus 2 less than we can put epsilon over 15. So this implies x minus 2 times 15 less than epsilon. Now what we're going to do, we're going to replace 15 by the expression, because if you put the expression that is smaller, the implication works. So what we do, instead of 15, now we can write 3x plus 6 less than epsilon. That implies that, directly implies that what we want. Since the left hand side is equals to this one, so you can write this one as 3x squared plus 4 minus 16 less than epsilon, because they are all equal. So that completes the proof. This completes the proof. So that's how you make the logical argument for a problem like this. So let's look at the next one. So as the next one, we have limit x goes to 1, 4 plus x minus 3x squared equal 2. So we do exactly the same way we did before. So the proof. So we're going to say let epsilon positive. Then what we can do is we can write several implications. So we can start with what we want to prove. So it is 4 plus x minus 3x squared minus 2, which is less than epsilon. That's how we prove. This implies like it's like double implication. This is if and only if. What we're going to do, we're going to simplify the left hand side. So if you simplify, you're going to get 2 plus x minus 3x squared less than epsilon. This is if and only if. You know that inside the absolute value you can switch the order. So we can write this one as 3x squared. So you can simply multiply by negative sign. So 3x squared and then minus x minus 2. That's exactly the same. You can always switch inside the absolute sign. Now we can factor. So you can see that this has factors. This again if and only if they are all equal. X minus 1 times the other factor is 3x plus 2 less than epsilon. Now this again if and only if. You can write this one as, if you pull the x minus 1 out, you get the other factor, which is 3x plus 2. 3x plus 2. So now what we want to do is to find the largest value of this one. So this is very similar to the previous one. What we're gonna bound x minus 1 first. So we can say that, so we're gonna bound that. So we use the same trick every time. So this is around 1. So we're gonna pick x minus 1 less than 1 again. So that's what we're trying to do. So that means it's gonna go up to 2 and 0. So 0 and 2. Since we are looking for the largest value, we pick this side because we pick 2 here. So that's the largest value. So we're gonna pick that one. So that means then we can see that if you pick the largest value, so x equals 2, so you get 3x plus 2 equals to 8. So that means now we have only single implication. It's only go left side. So this, you can see that. Then we can write, if you pick the largest value, we have implication to the left side. So it's gonna see we pick the larger. That's the largest value of 3x plus 2. So it's 8 less than. So what we can do, we want to make sure that now we're going to pick a delta, so that 8 times delta is smaller than epsilon. So that means we're going to pick a, now we're going to pick a smaller delta. So we pick a smaller delta, so that 8 times, delta, so it doesn't, both looks like 8. So it is 8 times delta is less than or equal to epsilon. That means if you simplify for delta, you're going to see that delta is less than or equal epsilon over 8. So that means then what we can do, we can pick a value that satisfies both conditions. So that means now we say choose delta equal the minimum of the two, minimum of 1 and epsilon over 8. So then we have this simplification. So we can see that because of this double implication, we can simply write 0 less than x minus 1 less than delta implies, because the double implication, we can say x minus 1 less than epsilon over 8. So you can pick anything because that's the smallest. Now this implies that 4 plus x minus 3x squared minus 2 less than epsilon. So that completes the proof. So as the next one, we have limit u goes to 1, 3 over u plus 2 equal 1. And you can see that this is a rational function, so you want to make sure that you do not include the value negative 2, because that value is gonna give you something undefined. So let's see how it works. So the proof, so let epsilon be positive, then you can write this statement, and you can say 3 over u plus 2 minus 1, that's the difference between the function and limit, less than epsilon if and only if we're going to simplify inside. So if you simplify inside, that means you're going to do cross multiplication. You can write this one as 3 minus u plus 2 over u plus 2 less than epsilon. So this is if and only if. And again, this is if and only if. You can see at the top, you can simplify as 1 minus u, absolute value, and then again u plus 2 absolutely, since we don't know whether it's positive, so we're going to leave it like that. And then you can also switch the top because it's under absolute sign, so you can switch the top and also isolate this term u plus 2 absolute value. Now your goal is to find the largest value of this expression. That's not that difficult. So what we can do, as before, we can restrict the domain for u. So that means so let's do that. So u is around 1, and then again, so we're gonna say u minus 1 less than 1, not x. So u minus 1 less than 1. So when you do that, then you're gonna see that this is 2 and 0. So now, so let's see that. So we're gonna pick the values in this interval. So we're gonna pick the values only in this interval, but we are looking for the largest possible value. Since this is in the denominator, now we're going to pick the value on the other corner, because this is the value we're going to pick. So now we pick the smallest value. When you pick the smallest value, you get the largest fraction. So once you plug in the smallest value, that means 0, and you can see that you can write this sentence. So we can say, so this is left implied that u minus 1 absolute value. Now you're going to pick the largest value. If you pick the largest value, then it's going to give a left implication. So less than, now again we restrict this side u minus 1 by delta. So that means you can see that uh, we want to make sure that this is within the less than epsilon. So what we can do, we're going to pick a value, a delta, so that the half times delta, because half is the largest possible value you can get from the other expression. So the half delta, so you pick a smaller delta so that half delta is smaller than epsilon. So it's very clear. So that means, and then we're gonna use this to simplify for delta. So this says that delta is smaller than 2 epsilon. So we're gonna choose a delta which is smaller than 1 and 2 epsilon. So now, so it's as before. So you can see that choose. So I'm going to show you a different argument this time. So let's say choose, because you know that you can pick either a delta equal, it's a less than or equal. So it's a delta equal 2 epsilon or any smaller one. So let's say, for example, you're going to pick delta equal epsilon this time and see how the argument works. So delta equal minimum. So you can pick either minimum of 1 and 2 epsilon or even any other epsilon. So let's say you pick epsilon in this case. So let's see how the argument works now. So then you can write this. Then 0 less than u minus 1 less than delta implies that u minus 1 is less than epsilon, because that's how we pick the delta. It has to be smaller than any of them. But you know that this is smaller than 2 epsilon. So that's how you're going to jump through this step. Now what we can do, we're going to skip the epsilon, we're going to go with the 2 epsilon. So that means this implies, now you can say that u minus 1, I'm going to divide by half. So I'm going to say, okay, let's try this step. So this is true now. Now what we can do, we can divide by 2 both sides. And then since epsilon 1/2 is the largest value, this implies u minus 1. So we're going to put u plus 2 absolute value back in there. Now you're going to combine. So you can see that because of the argument we write, because of the double implication we wrote, this is exactly similar to 3 over u plus 2 minus 1. That's exactly similar, less than epsilon. So that means that's exactly what we want to prove. So this completes the proof. This completes the proof. So you can see that it doesn't take much time, and if you understand how the argument works, and so you can see that we can even pick a small epsilon, but still the argument works. Good. So let's look at the next one. So as the next one, we have limit t goes to -1, 6 minus 3t square root equal 3. So we're gonna do a similar argument here, but we're gonna use the simplification step now. No implications. So let's say proof. So we pick a epsilon. So let epsilon be positive. So we pick a positive epsilon. And note that. So I'll write different type of proofs so that you can learn different arguments. So let's say we can start with what we want to prove. 6 minus 3t square root minus 3, that's the limit and the function. This is equals to, again we're going to multiply the top and bottom by the, so we have 6 minus 3t square root minus 3, that's the first term, times, so we're going to multiply the conjugate of this. So we only change the sign between, not inside. So that means we have 6 minus 3t square root plus 3, and we divide by the same thing, 6 minus 3t square root plus 3. No epsilon here. Now what we can do, we're going to combine the top. So it's because of the difference of squares formula. You can see the top is now 6 minus 3t minus 9, and we put absolute sign here, and then the bottom you can say 6 minus 3t square root plus 3. We don't need the absolute sign. The reason is this term is greater than or equal to 0. Now you can see that top simplifies to negative 3t negative 3, and then the bottom is 6 minus 3t square root plus 3. And what you can do, you can pull 3 out, and also you can cancel the negative sign. You can write this one as 3t plus 1 over 6 plus not 6 plus 6 minus 3t square root plus 3. And then what we can do is we can use a similar argument, and you can see that this is less than, or equal, because it can be 0, so less than or equal to, you can write this one as t plus 1 times 3 from the top, and you can see the largest value. That means we're going to pick the smallest value from the bottom, which is 3. So you can write it like that. And then what we can do is we're going to pick a delta which is smaller, and the same argument. So we can see that, so this simplifies to simply 1. 3 means 1, so that means we pick a delta so that this is smaller than less than or equal to epsilon. So again, just to make sure that you do not get any undefined values, as before, we're going to restrict the domain, and we take epsilon is the minimum between 1 and epsilon. You can see this argument is very clear now. So we can say taking a delta which is the minimum of 1 and epsilon, we have 0 less than t minus 1. So you can write it like that. That's what t plus 1 means. Less than delta implies that t plus 1. It's the same thing. Less than epsilon, because it's the minimum. Delta is the minimum of the two. That means to be smaller than any of them. Now again, we can write this one as this is exactly the same as t plus 1 over, so 6 minus 3t, because this is a smaller value, plus 3. We multiply by something smaller, maybe the largest possible value. So this is smaller, and then you can see that this simplifies to, because of the equality, 6 minus 3t. Let's say you have to do that first. 6 minus 3t minus 3 absolute value less than epsilon. So that's exactly what and you can see that this implication works very well. So then we can see thus, summarize the complete thus for all epsilon there is a delta positive such that for all x in the domain of the function, that's very important, the function 0, because sometimes we don't write this one because that's gonna make the whole argument wrong, because if you get some values which are not in the domain, the implication does not follow. So it is x, so t minus 1 less than delta implies 6 minus 3t square root minus 3 less than epsilon. So that's exactly the epsilon delta argument. So therefore, you can say therefore by the definition, limit t goes to -1, 6 minus 3t equal 3. So that completes the proof. So let's do one last problem. So problem number 8. So as the next problem, we have limit x goes to 5, 7 over x minus 1 square root, which is equal to 7/2. So this is like a rational and root. So let's see how the algebra works. So the proof. So we're gonna say let epsilon positive. Then note that what we can do the algebra first. So we write 7 over x minus 1 square root minus 7/2 equal. This is equal. So we can pull 7. Then we're gonna get 1 over x minus 1 square root 1/2. Now we can do the cross multiplication and write this as 2 minus x minus 1 square root over 2 times x minus 1 square root. So what happened here is when you have AB minus CD, you can write this one as AD minus BC over BD. So this is how we normally do this algebra. So that's the cross multiplication. You can see that AD minus BC is the cross multiplication. You can always do that. So now what we can do is, since we know that x minus 1 square root is greater than or equals 0, we're going to pull that out of the absolute sign. So that means we can write this one as 7 over 2 x minus 1 square root. And then the rest we have 2 minus x minus 1 square root. So what we're going to do now, this is just a like square root type of problem. That means we're going to use the conjugate method now. So which is 7 over 2 x minus 1 square root. So we're going to multiply the top and bottom by square root. So the 2 conjugate. So it is x minus 1 square root. And be careful, conjugate has changed the sign only of this one, not inside. So that means times, the conjugate would be 2 plus x minus 1 square root. Then 2 plus x minus 1 square, because this is simply 1. So now you can simplify the top using the difference of squares argument. A minus b, a plus b equal a squared minus b squared. That means you're going to square the top. So we're going to get 7 over 2 x minus 1 square root. So you can see the top is 4 minus, you square x minus 1. That's the top. And then the bottom, you can see it is 2 plus x minus 1 square root. That you can bring out because that's always positive. So that means now what we can do is, you can see this simplifies very well. So we can write this one as, the top is just 5 minus x, which you can write as x minus 5. So you can say x minus 5 absolute value, that's the top, that is this one. And then I'm going to combine everything else to one expression. So the rest you can write as 7 over 2 x minus 1 square root. And the other whole expression you can write it because it's positive. So you don't need the absolute sign anymore. You can write this one as x minus 1. Yep, write it like that. Now what we're going to do, we're going to find the largest value of this expression. So that's not that difficult to find. We're going to do a similar argument. We restrict the domain. So once you restrict the domain, so what we're going to do, we're going to say, okay, we're going to pick values x minus 5 less than 1. Again, it still works. Sometimes this x equal, sometimes this 1 may not work. Then you might have to say half or something smaller one, because you want to make sure that you do not include any, like you, in this case, you do not include x equal 1. So that's the troublemaker. So x cannot be 1. And also actually you can see, so you can have, so what it says that, because this is square root, you want to make sure that x is bigger than 1. Because you cannot have any smaller value, like you cannot have 0 there. So it's actually bigger than 1. So that's what you want to make sure that, and then if you do it like that, it's exactly work, because you're going to see 5 around like you go only 1 away, so that means it's gonna be 6 and 4. So everything looks good. So now since all these terms are in the denominator, so what we're trying to do is we're gonna pick smaller values. So we're gonna pick smaller values. So you can pick the smallest value. Because when you plug the smallest value, you get the largest fraction, and you can see that if you plug in values, for example, if you plug in 4, the x minus 1 square root is going to be square root 3. So the square root 3. So that means you can see that this expression is, you can see, so this is smaller than, so you can see that this expression in red is smaller than 2 because the bottom can be larger than 4. Since the bottom can be larger than 4, this expression can be the largest value is smaller than 2. So that means what we're going to do, we're going to find a delta, so that 2 times delta, because 2 is much bigger than this fraction, less than, so we find a smaller delta, so that 2 times delta is smaller than epsilon. Now we can use this to write the argument. So we're going to say, so then choose, so you can say choosing delta as the minimum of 1 and epsilon over, so you can see 2, because when you have 2 delta, so what we have is 2 delta less than or equal epsilon. That means delta is less than or equal epsilon over 2. So then we can write, so we have all the nice implications. 0 less than x minus 5 less than delta, which implies x minus 5 less than epsilon over 2, because you can pick anything you like. Then multiply by 2, we can write this one as x minus 5 times 2 less than epsilon. Since 2 is the largest value, you can replace this one by something smaller. So you can write this one as 7 over the large expression 2x minus 1 square root times 2 plus x minus 1 square root less than epsilon. And now you can see that this all simplifies to 7 over x minus 1, because that's what we get, over 7 half minus 7 half less than epsilon. So therefore so we have, therefore by the definition we prove that the limit x goes to 5, 7 over x minus 1 square root equals 7 half. So this completes the proof. So you can try the last one as an exercise. So see whether you can prove this problem as an exercise. So it shouldn't be difficult. Thank you for watching.